All right, in this video, I'm going to do a review of 5 of the most important questions, or just 5 important questions from chapter number 1. So you can use this review as kind of a bit of a study for your test. I'm going to try and get through all these questions as quickly as possible. So if you have not too much time to review for your test and you're just looking for a quick review of 5 of the most important questions from chapter 1, you can go through this video. I'm gonna try to get through as quickly as possible. So if I make any mistakes, let me know in the comments. And if you want to try these questions yourself, just pause the video right here, try the questions first, and then take a look at the solutions. So let's get into it. Question number 1, state the domain and range of each relation, determine whether it's a function, justify your answer. I'm going to sketch these out as well. So first one over there is a quadratic equation. Just going to sketch them out for your knowledge as well. The vertex is -1, -3, and it opens down because it's negative. So that's what my graph looks like. My domain is just x is an element of all real numbers because it goes to the left and right towards infinity. And my range is just y is less than or equal to -3 because my max value is -3. And this is a function because it passes our vertical line test or because it's quadratic. Second question over there is a 1 over x function. 1 over x functions have vertical and horizontal asymptotes. My vertical asymptote is based on the denominator. It's the opposite of that. So it's at x equals -3. My horizontal asymptote is a number at the right over here, which is just 0. There's no reflections, so I'm on the original 2 quadrants, which are like this. And then my domain is just x is an element of all real numbers, such that x does not equal to my vertical asymptote, which is -3. Y is an element of all real numbers, such that y does not equal to 0. And this 1 over x function is also always going to be a function. Third one right there, it's an exponential equation. For exponential equations, we draw a horizontal asymptote, which is the constant at the end, which is 0. This is exponential growth, which will be going up like that, but we have a reflection in the y-axis, which makes it look like this. Domain is x is an element of all real numbers because it goes left and right forever. Range is just y is greater than my vertical asymptote because I'm above the vertical asymptote in this question. Again, exponential relations are always functions. Fourth one here is a cos graph. It's just cos x plus 1, which means that the 1 is where I draw my equation of axis to begin with. Oops, that's not really an asymptote, that's an equation of axis. My max, I add my amplitude, which is 1. So my max is at 2, and my min, I subtract my amplitude, which is at 0. Then I just draw a cosine wave. Goes in that direction forever. So my domain for this one is just x is an element of all real numbers. And my range is y is an element of all real numbers, such that my minimum is 0 and my maximum is 2. Again, this one, all cosine and sine functions are functions because they pass the vertical line test. Next one, there's an equation of circle, and my radius is square root of 9, which is 3, centered at 0, 0. That's what the graph looks like. My domain for this function is x, e, r, and x is between -3 and 3. My range is y, e, r, same between -3 and 3. This one is not a function because it does not pass the vertical line test. Last one is 2 sine x, sine graph. Equation of axis is just at 0. My amplitude is 2 for this one. So my maximum is 0 plus 2, which is 2. My minimum is 0 minus 2, which is negative 2. You can draw a sine graph then. Domain is just all real numbers. Range is between negative 2 and positive 2, and then this one is a function. First question there, domain and range. Let's go to the second function over here. Find f of negative x, negative f of x. Basically, use it to define whether the functions are even, odd, or neither. So let's start with the first one. We have f of x equals x squared minus 4. We always start by finding f of negative x first. So f of negative x is just negative x squared minus 4. Negative x squared is just x squared minus 4. And if I compare this to the original, they're both exactly the same, which makes this an even function. Let's try the second one over here. Let's find f of negative x to begin with. So that's 2 times negative x cubed plus negative x, which is 2 times negative x cubed. Negative x cubed is just negative x cubed. Negative times positive is negative x. 2 times this is negative x, negative 2 x cubed minus x. This is not the same as the original. So let's find negative f of x. A little bit of a typo here as well. There should not have been a negative there. And just finding negative f of x to prove for odd and trying to see whether it's the same as this. So to find negative f of x, I'm just going to sub in negative and then put the entire function there and distribute this negative into the function. Then compare it to f of negative x. So if these two are the same, that means that my function is odd. Let's try this third example over here. Start by finding f of negative x. That's 2 times negative x squared minus negative x, which is negative x squared is positive. And then let's find, this is not the same as that, plus and minus. So let's find negative f of x. That's just negative 2x squared minus x, which is negative 2x squared plus x. And this is not the same as this because we have this minus here. So this one is neither odd or even. Third question. Each of the following equations state the parent function, the transformations, and graph the transform function. So this is about knowing how to describe your transformations. First one here, the parent function is just exponential. It's just 2 to the power of x. The transformation 0.5, that is a k value, which is a horizontal stretch because it's less than 1 by a factor of, and we always got to do 1 divided by that number. So it's going to be 2. 1 divided by 0.5 is 2. That's the only transformation. And then to graph this function, just going to sketch it. The horizontal asymptote is at 0. And it's exponential growth. So it just looks like that. Second question over there. Again, that's a k value, that's a d value. Parent function is just y equals sine x. That is going to be a horizontal compression in this case because the value is larger than 1 by a factor of 1 over 3. And that is a vertical translation up by 1 unit. I'm graphing this. It's a sine function. So equation of axis is basically at 1. Amplitude is 1, so my maximum is at 2 and my minimum is at 0. It's a sine function. Draw out a little bit of a sine function here. Then it's a horizontal compression by a factor of 1/3. So normally one wave, normally this over here is 360, but it's compressed by 1/3, which means that this over here is 120, which means this is 60, means this is 30, and this is 90. And let's take a look at that third one over there. Y equals to root 2. So that is going to give me a parent function of root x. Two transformations, this one k value and d value. So my k value is 2, which means it's a horizontal compression by a factor of 1 over 2. And then that's a horizontal translation 6 units to the right. Plotting this out, vertex is just at positive 6 and 0. And there are no reflections, so it just goes in the regular direction, a square root graph. I'm going to do one more transformation question that I didn't include there with some extra transformations, just so that you understand transformations better. I'll just do y equals to 3 bracket 1 over 4 x plus 2 square minus 1. Just add an extra one that's a bit harder with more transformations to this video, so that you understand it a bit better. So over here, parent function is just y equals x squared. This is a vertical stretch because it's larger than 1. So larger than 1 means stretch, smaller than 1 means compression. That's my a value. Don't have to flip this. It's the opposite for this over here. That's going to be a horizontal stretch because it's smaller than 1, and we have to flip it. So for horizontal translation, right, oops, left, all right, 2 units, vertical translation, down 1 unit. Then when sketching this out, it's a quadratic equation. My vertex is at -2, -1. You know what? I'll add a reflection as well over here. Let's say there was a negative over here. Then that's a reflection. First transformation will be a reflection in the x-axis. Just wanted to make it a bit more complicated, show you how if there was a negative on the inside, that's a reflection in the y-axis. So -2, -1 is my vertex, and then it opens down because it's reflected in the x-axis. Okay, let's go to the next fourth question of this video. Determine the inverse of each function. So to find the inverse of the function, we start by switching our x's and our y's. X equals -2y plus 5. Now all we have to do is isolate the y. Start by moving the -2 over. Divide it on the other side. Then I'll subtract the 5. And instead of writing y when it's isolated in the last step, I'm going to rewrite m inverse of x. Let's try it for the second one over here. X equals y cubed minus 1. X plus 1 equals y cubed. Got a cube root the other side. So cube root x plus 1 equals g inverse of x. Last one there. X equals to 4, y minus 3 plus 1. X minus 1 equals 4, y minus 3. Square. X minus 1 over 4 equals y minus 3 square. Square root x minus 1 over 4. Make sure you put the plus or minus, equals y minus 3. And when we move the 3, we can move to the front or the back. It doesn't matter. Just going to move to the front. So 3 plus or minus square root x minus 1 over 4 equals h inverse of x. Finally, last question of this video, graphing piecewise functions. So graph the piecewise functions, determine whether they're continuous or not, and state the domain and range of the function. So let's start with the first one over here. Whenever you're graphing a piecewise function, you want to start by just drawing your axis. It can be on graph paper if you're given graph paper. Then you want to mark the x value that's important, which is positive 2. You want to start by just drawing the left-sided function first. So I know x squared plus 1 is just a quadratic function that looks like that. So I need to draw just this half of the function over here. So if I sub in 2 into this, 2 squared plus 1, that's 4 plus 1, which is 5. So this is what the left side of the function looks like. The dot over here will be empty because it's just less than for the first function. Then for the second function, 2x plus 1, that's just a linear function. Y-intercept is 1, slope is positive 2. It just looks like that. And then for this one, I'm just drawing the right side of the function on this. So I'll start by subbing in 2 into this equation. 2 times 2 is 4 plus 1 is 5. Which is the exact same spot. I'm going to fill it up because it's greater than equals in this case. And then I'm just going to draw that linear function over there, which goes like that. That's the graph of the function over there. This function is continuous because there's no discontinuities anywhere. The domain, it goes to the left forever, it goes to the right forever. There's no gaps in between. So domain is just x is an element of all real number. Range is y is an element of all real numbers, such that the minimum y has to be greater than or equal to 1. And let's try the last question of this video, again graphing this piecewise function over here. So for this one, my important x values are -1 and positive 3. So -1, positive 3, always mark those down first. The left-sided function is just a horizontal line at positive 1, and then it's an empty dot. So horizontal line, empty dot. The second part of the function is a linear function, which is x plus 2. So if I sub in -1 into x plus 2, -1 plus 2 is +1. It's also inclusive for both of these. So +1 is going to fill in this exact dot right there. The y-intercept of this linear function is +2, goes up like that. This is inclusive over here as well. And to find the y value over here, I will sub in 3 into this function. 3 plus 2 is 5. The third function is just a horizontal line again at 5, and that's just greater than 3, which is basically just a horizontal line over there, making this function continuous everywhere as well too, because there are no discontinuities. And the domain, it goes to the left forever, right forever. There's no discontinuities. It's XER. The range, the minimum is 1. The maximum is 5. So my range is between 1 and 5. Okay, so that covers it for this video. Hopefully you'll find this helpful for your test. If you do find it helpful, please hit that like and subscribe button. Thank you for watching and good luck for your test and have a nice day.